Today, more than ever before, it is of paramount importance to industry that raw materials, components and finished products should be handled in an efficient manner, making the best possible use of expensive manpower. The correct solutions to the handling problems which arise are as individual and as varied as the loads themselves. The British Monorail Company of Brighouse have the know-how, coupled with the design and manufacturing facilities, to supply and put to work custom-built installations with the minimum cost and delivery times by making the maximum use of standardized components. In this film, we're going to look at a dozen different installations, some simple, some highly sophisticated, but all illustrating through their performance how British Monorail have played their part in the vital drive for industrial efficiency. Nowhere is automated handling more important than in the production of motor vehicles, as typified in this automatic runway installation. The system is fitted with specially designed powered lifting units used in conjunction with automatic grab attachments to handle car underframes. After the final welding operation, the underframes are rotated and automatically picked up by the grab attachments. The units on each system are electrically interlocked so that a loaded unit is always ready to move forward for delivery to the production lines. Several systems are installed side by side, and automatic glide switches are provided, enabling the lifting units to transfer from one system to another as required. Manual operation is employed to lower the underframes onto the body assembly lines. All other operations are automatic. The articulated construction of the lifting units enables sharp corners to be negotiated. Smooth and noise-free motive power is supplied to the units by monotractor drives, consisting of a rubber-tired wheel spring-loaded against the underside of the beam. As in many other processes, the handling of dirty laundry has until quite recently received less attention than the mechanization of the washing process itself. Full advantage of modern machine capacity can only be obtained by the use of modern handling equipment. In this hospital laundry, the soiled linen is automatically washed in 200-pound dry weight lots. The wet loads are discharged onto belt conveyors. Each machine load, individually weighing about 600 pounds in the wet condition, is dropped into a special quick-release sling bag. The bags are hooked onto two-wheel trolleys running on a lift beam of monorail track, which has been lowered to a convenient height. The beam is raised to interlock with the main runway circuit by a pneumatically operated cylinder. A stop is operated, allowing the bags to gravitate forward for squeeze drying. The open ends of the track are protected by these stops whilst the lift beam is in use. Most of the water is removed by squeezing the bags of washing under hydraulic pressure in a bank of hydraxter units. When the hydraxter cycle is completed, the operator lowers the beam, attaches the bags, and raises the beam to track height again. The bags of semi-dried washing are then transferred from the lifting beam to the gravity section, where they travel to the unloading point. Here the bags are unloaded into containers for transfer to the finishing processes. A common problem is the movement of large quantities of relatively light products through production processes or from manufacture into storage. The loads are often fragile and readily damaged. The Cableway conveyor can efficiently handle practically any number of unit loads and follow any required path through a working area. After loading, the conveyor climbs to roof height and continues on its way without interfering with the working space below. Frequent changes in vertical height and horizontal direction can be made with provision for any number of load-unload operations. The carriers, which are suspended from two-wheeled ball-bearing trolleys running on a special T-section track, are connected together by an endless steel cable and driven from one or several points around the circuit. A large variety of fixed speeds is available, and infinitely variable speeds can also be provided. Systems up to several thousand feet in length are common. This particular conveyor is 1,100 feet in length and is driven by two motors of 1.5 horsepower each. A raw material store handling a large selection of long steel bars is serviced by a standard double bridge railmaster crane adapted to lift at 2 points and equipped with an automatic beam attachment for picking up the bars which are stored in cradles. The lifting unit consists of an orthodox electric hoist with the ropes reeved out from the barrel and down to two separate hooks. This ensures that the loads are maintained in a stable, horizontal position. Once again, smooth and trouble-free operation on both long and cross-travel motions is ensured by the use of monotractor rubber-tired drives. Using this type of system, it's possible to block store a high volume of materials whilst preserving good selectivity. Control problems by advanced electronic techniques has resulted in the linear motor becoming available for a large variety of crane drive applications. The linear motor is basically the stator of a normal rotary induction motor opened out flat. The motor is installed immediately underneath the track on which the crane runs, with a small air gap maintained in between. The track, in fact, acts as the motor rotor, and an extremely smooth travel is obtained without the use of gears, clutches, or transmission shafts. The motor is encapsulated and is thus impervious to the effects of external atmospheric conditions. Sophisticated handling machines available today is the stacker crane. A stacker crane has the operational advantages of an orthodox overhead traveling crane with the additional flexibility provided by a rigid mast replacing the normal suspended hook. This crane is capable of handling steel coils of up to 15 tons in weight and is fitted with a two-stage telescoping mast, thus enabling it to pick up direct from lorries and place into storage racks. The use of a telescoping mast can eliminate the necessity for costly and in many cases inconvenient loading bays. The operator travels with the load, enabling extremely precise and accurate movements to be carried out. The long travel, cross travel and slewing motions are electrically controlled, whilst the hoisting motion is hydraulic in operation. The operator's controls are neatly arranged on a desk-type console in the cabin. The traditional system of coil storage is to stack the coils in pyramid fashion on the floor. This is potentially dangerous to personnel and can result in considerable damage to the coils themselves. This crane enables the coils to be stacked individually in racking, so that each coil is completely accessible at any time. Thus, storage space is considerably reduced, together with total stock investment. The crane mast slews continuously through 360 degrees. The circular cant shock conductors supplying current to the mast section are clearly visible. Telescopic mast stacker crane is handling special steel sections in a stock holding warehouse. The majority of the bars are circular in section and consequently require particularly careful handling. The bars are stored in cantilever type racking and vary considerably in length, cross-section and material specification. The fork carriage is fitted with hydraulically tilting forks so that the cylindrical loads may be handled in a stable fashion. The forks are also capable of being driven electrically so that the horizontal centers may be varied to suit the different lengths of load. A lighter capacity but equally sophisticated installation consists of 3 underslung crane bridges running in parallel bays equipped with a total of 2 stacker masts. The underslung construction enables either of the 2 stacker masts to be transferred from one crane bridge to another through interlocking crossover sections between the bays. The cranes are used to handle post pallets and palletized cases containing engineering components. The loads are block stacked, an arrangement which permits maximum volumetric utilization. The operator is at all times adjacent to his load, enabling him to exercise accurate control. The open ends of the crane bridges are protected by automatic stops, which are released when the cranes align into the interlock position, thus allowing the stacker mast to travel from one bay to another. Drive is by tandem rubber tires, and cant shock insulated conductor bars supply the current. The provision of telescopic masts allows lorry loading and unloading to be readily undertaken, and the ability to operate several motions at once permits minimum handling times to be achieved. The provision of a spare parts store for handling many thousands of diesel engine components, varying considerably in unit weight and size, presents many problems. The handling of heavier loads into and out of the racking system is undertaken by British Monorail pallet handling cranes equipped with rigid masts fitted with fork carriages housing three-stage telescopic forks. These forks are capable of depositing or retrieving palletized loads from either side of the aisle and of operating in an aisle only some 4 inches greater than the maximum width of the pallet itself. The slide-through fork is precision-made and is designed to occupy the minimum depth. The intermediate stage is directly driven from the fixed bottom stage by rack and gear train. The top stage is driven from the intermediate stage, all loadings being transmitted through heavy-duty maximum diameter needle roller bearings. For retrieving smaller, more frequently required components from the extensive bin-type racking system, order picking cranes are used. These are similar in construction to the pallet handling cranes, except that the forks are replaced by an operator's cabin, containing storage facilities for the individual components. Access to the 36,000 stock locations in the bin system is rapid, and hoisting and travelling motions take place simultaneously, thus allowing the quickest possible journey to be made. The cranes run on a floor-mounted rail down the centre of the aisle and are stabilized by rollers at the top of the racking. Operators pick from various locations in accordance with a predetermined picking list, and completed orders are then transferred to the end of the aisles for packing and dispatch. This installation, and with the receipt, bulk storage and subsequent dispatch to individual customers of a great variety of gas appliances. The racking system and the stacker cranes are completely integrated with newly delivered appliances being fed into the primary input racking. The first stacker crane retrieves goods from the input racking and loads them into pre-selected lanes in the main storage racking. When goods are required, they're picked from the main storage racking by the second stacker crane and placed in the order picking racking. Appliances to make up individual orders are picked from this racking by 3 order picking stacker cranes working on the order picking face. The input crane travels the aisle between the primary and bulk storage racking, transferring loads from one set of racks to the other. All the cranes in this installation are of twin-mast construction. The 42-foot high box section masts are supported by a 2-wheel carriage running on a single floor-mounted rail. Palletized loads are removed from the primary storage racking by means of a 3-stage telescopic fork. The following loads in the storage lane automatically move up 1 pallet length in readiness for the next operation. The cranes are controlled by punch paper tape, produced by a stock control computer some 18 miles away and connected to the warehouse by data link. Overriding manual control is also available as required. Loads are discharged into the required lane of the bulk storage racking and gravitate towards the transfer face. The cranes are fitted with sophisticated amplidyne-controlled DC travel and 2-speed hoist equipment, so that precise lining up under automatic control is possible. Immediately the palletized load has been fully retracted, the crane automatically starts away and accelerates towards its predetermined destination in the order picking racking, with both travel and hoisting motions operating in unison. Three automatic order-picking cranes with manual pre-selection operate on the output face of the racking. These cranes are of somewhat similar construction to the pallet handling cranes, but are fitted with large order-picking cages instead of telescopic forks. These cranes overlap on their travel motions, thus ensuring that the whole face of the racking is covered. Interlocks are provided to prevent any danger of collision. The cages of the cranes are fitted with mid-bar collapsible gates, electrically interlocked to prevent inadvertent operation, other than when the crane is stationary at a pre-selected point. In this sophisticated installation, the warehouse is virtually built round the cranes and racking and is integrated with a computerized stock control at a remote location. Details of incoming goods to the warehouse are transmitted to the computer, which updates the stock records and instructs the first stacker crane to place the appliances into the appropriate sections of the racking installation. As individual dispatch orders are received, they are processed by the computer, which programs the transfer crane to supply 3 sections of the order picking face with sufficient appliances to meet current orders. The dependability of the British monorail cranes and the accuracy of their comprehensive controls enables them to become a vital part of a computerized stock control system and gives the integrated warehouse extremely high throughput with minimum labor requirements. This is designed to handle rolls of broadloom carpet up to 15 feet in length into and out of a racking complex some 200 feet long and 48 feet in overall height. The crane is capable of carrying 4 rolls of carpet simultaneously, the rolls being supported on wooden platens. The hoist drive is by a heavy-duty slip-ring motor equipped with a thruster brake which provides the creep speed. All operations are controlled by the operator from a push-button console located in the central gangway of the hoist carriage. Ball-bearing rollers are fitted to the crane platform and the carpet racking to facilitate easy movement of the carpet platens into and out of the racking. A rather different solution to a somewhat similar problem is shown in this installation, which comprises a total of 5 carpet handling stacker cranes, each operating in its own aisle. The cranes are some 48 feet in total height, and the carpets are handled on booms which pass into the bore of the rolls of carpet. This bore is protected by a cardboard tube which is used as part of the carpet manufacturing process. An extremely compact storage arrangement is made possible within the storage area by the use of a high bay racking complex. The cranes are fitted with three-way radio, thus allowing instant contact between the various crane operators and the warehouse input and output dispatch supervisors. The excellent maneuverability of the cranes can readily be appreciated as the crane slews through 180 degrees whilst travelling down an aisle. The operator is housed in a compact cabin with controls at his fingertips. The cabin is attached to the boom carriage, and consequently the operator travels with the load, enabling eye-level viewing during all operations. The dispatch and input points are on split levels and integrated with the warehouse conveyor system. This ensures extremely fast handling and immediate access to any of the 14,000 rolls of carpet stored in this warehouse. The flow patterns of carpet into and out of the racking complex divide into two paths. Some carpets are dispatched as complete rolls, others go to the workroom for cut lengths to be removed. In the same way, the warehouse input combines newly manufactured 850-pound complete rolls with part rolls returned to the store from the cutting section. This carpet warehouse is another example of a storage complex where the shell is purpose-built around the handling and racking system. The British Monorail stacker cranes, working in conjunction with the high-rise racking, enable up to 3,000 rolls to be handled in a day, at the same time ensuring the best possible realization of site value and reducing considerably the building cost per cubic foot of warehouse space. In this film, you have seen how British Monorail custom-built installations have helped a number of companies to solve individual handling problems. British Monorail can supply an answer to your handling problem, tailor-made to meet your exact requirements. Their wide range of standardized components and sub-assemblies keeps costs down to an economic level and enables realistic delivery dates to be maintained. Handling is an expensive item, often increasing total manufacturing costs by 20% or even more. British Monorail can help you to make it an economic and productive aspect of your business.